Happy Wednesday, 8th graders. We are going to move on to 8.2. We're going to talk about some more characteristics of quadratic functions today. Here we're going into a little bit more detail than what we did on Monday, and these things are going to help us graph a parabola or a quadratic function without having to plug and chug. It's going to make life a little bit less complicated. Before we actually do our graphing, we're just going to go over some of the key points and characteristics, and that is what our assignment is going to be today. All right, so again, lots of words on this slide. Let's write down this definition here. So the first characteristic we're going to talk about is a zero of a function. So a zero of a function is an x value, keyword x value, that makes the function equal to 0. Okay, so it can have, any quadratic can have 1 0, 2 zeros, or no zeros at all. And once we do a couple problems, that'll kind of make sense for you. So if we look at this graph, we can find the zeros of the quadratic function just from looking at the graph. Okay, then once we find those, we can check our answer. So if you can sketch this graph, or if you have a graph paper sitting around, you can use that as well. If we look, the graph shows us that our parabola crosses over in two different spots here. Okay, so we're going to have 2 zeros to this function. The zeros appear to be -1. This is where one of the x values yields a 0 y value, and +3 where the other one also appears to yield a 0. Now, we say appear because when we have a graph, especially with a parabola, things aren't always 100% accurate. There's a lot of sketching involved with a parabola. So it looks like those are the zeros. To make sure, we're going to plug our numbers in. So we're going to plug -1 into our function. And when we do, we indeed get a 0. And then we're going to plug 3 into our function. And again, we get a 0. So those are our zeros. Okay, so that first example had 2 zeros. Next example, again, if you can sketch this is great. If not, just kind of follow along. Here it appears that this graph only has 1 0. Okay, and it looks like it is -4. So notice the minimum is on the x-axis. So we're only going to have one minimum here. When it's on the x-axis, we're only going to have 1 0. Okay, again, if you plug -4 in and you plug and chug, you get 0. So that is the correct answer for the 0. How about this guy? Interesting. This does not cross the x-axis anywhere. So what are we thinking here? This does not have any zeros. You don't even have to, there's no calculation involved. Does not pass this x-axis at all. So therefore our answer is no zeros. Okay, so a lot of the times you can just look at the function via the graph and find what the zeros are, how many there are, or if there are any at all. Here's another one. We have 1 0. It looks like it's at 3. And when we plug it in, again, it works out to our advantage. Our y equals 0, so therefore our 0 for the quadratic is 3. Okay. Next characteristic we're going to talk about is the axis of symmetry. So as I mentioned in the previous lesson, if you were to fold your graph paper in half, you would see that it's a symmetrical parabola. So we have a line that divides that parabola in two, and that's called our axis of symmetry. So I want you to write down the definition. Also write down the notes here that you can find the axis of symmetry by using the zeros and also the fact that it passes through the vertex of the parabola. So make sure you're getting those keywords down, okay? All right, this is basically what we talked about. It's in your book. I just put this up in here for just another visual. If your vertex is on the x-axis, that means you have 1, 0. And if you look, the vertex here is 3, 0. Now notice your axis of symmetry is 3. That's exactly where the midpoint of that parabola is, right there. If you were to fold this in half, it would be right along the line of x equals 3. Okay, now if you have 2 zeros, it's a little bit more complicated. Again, like our example showed us, the 2 zeros, we pass through the axis of symmetry in 2 different points. I'm sorry, we pass through the x-axis at 2 different points. So now what we have to figure out is what's the average? What's the distance from like the middle? Okay, our vertex is -4. So the average here is -2, right? We're 2 spots away, and we're 2 spots away from these zeros, and it's covering or right on that x equals -2 line. So our axis of symmetry is -2. And that makes sense because our vertex is what point? -2, -4. Okay. All right. So again, if you can sketch these graphs, that would be great. Or if you could do it accurately, that would also be great. We're going to look at these graphs and try and find the axis of symmetry. So here we go. We have a smiley face. This one's easy because we got 1, 0, right? Our 0 is -1. Therefore, our axis of symmetry is also -1. Right here. Bam, right in the middle. Okay, the vertex is -1, 0. It's also our 0. There's only 1, 0, so our axis of symmetry is -1. Okay, example B. This one's a little bit trickier-ish. We have a 0 over here at 1 and a 0 at 4. If we find the average of those zeros, we get 2.5. And if you eyeball it, it looks like 2.5. You can't just say it's 2.5 by eyeballing it, but it does look like 2.5. So with our math, we proved that it was. So our axis of symmetry is x equals 2.5. Okay, next one right here. Again, we have 1, 0. You can identify what that point is. That's our axis of symmetry. And our axis of symmetry is -3. X equals -3. Okay. This one here, we have zeros at -2 and at +4. When we average those together, we get 1. And by golly, it sure looks like that axis of symmetry is at 1. X equals 1. Okay, now, if you have no zeros, this is where it makes life a little bit slightly more difficult. But not really. We always have a solution, right? So if your function has no zeros, or maybe you can't even identify because it's not like on a really like clean line or a clean coordinate point on your graph, then you can use a formula which works for all quadratic functions. Here's the formula that you can use. Okay, so I want you to write this down. You're going to use this when we graph, and you're going to use it obviously for tonight's homework. But if you want to find the axis of symmetry of any quadratic function, you use the formula x equals -b over 2a. -b over 2a. And we use the info. The number, the constant in front of x squared is a, and the constant in front of x is b. So we're going to use those two numbers. Be careful with the signs, of course. And we can always figure out our axis of symmetry. All right, so here we go. We have y equals -3x squared plus 10x plus 9. Trust me when I tell you that this is not an easy one to graph. So we don't have a graph. We can't just pull our info out from looking at a graph. So we're going to use our formula. First thing, just like when we're doing like slope and stuff, we identify what we need. We're identifying our a is -3 and our b is 10. Then we're going to plug that into the formula. Our formula is x equals negative b over 2a. Plug and chug. Be careful with the signs. This negative in the formula kind of is an overall negative. This whole formula is negative, okay? So if I plug 10 in for b, negative 3 in for 2, I get 10 over negative 6, which makes, and then the whole thing is negative. So a negative and a negative is a positive. When we reduce it, we get 5/3. So our axis of symmetry is 5/3. That would be really hard to extrapolate from a graph. That would be hard to see. Okay, so the formula comes in handy. All right, how about this one? Let's find the axis of symmetry of the graph of y equals 2x squared plus x plus 3. Our a is 2 and our b is 1. We're going to plug and chug into our formula. Negative b over 2a. So it's negative 1 over 2 times 2, or negative 1/4. Our axis of symmetry is negative 1/4. Again, that would be super hard to just extrapolate from looking at a graph. This formula comes in handy. All right, now, if you don't have a graph, once we find the axis of symmetry, we can then identify the vertex. If you recall back to looking at the graph, every time we found our axis of symmetry, it ran through our vertex. So if we find the x-coordinate of the vertex by finding the axis of symmetry, we can then plug it into our formula and find our y value. And then you simply write it as an ordered pair, and there's your vertex. Okay, so let's take a look at this here. We have y equals 0.25 x squared plus 2x plus 3. This is, I don't know. I look at this, I think this right here would be the axis of symmetry. And then we can find the vertex, and it looks pretty clear, but let's just be crystal clear by using our formulas. So the first thing we're going to do is find out the x-coordinate of our vertex. We see that our zeros are negative 6 and 2. We average them out, we get negative 4. Okay, again, if you can't figure that out by looking at the graph, you can use that formula we just did on the previous slide. Okay, now we're going to plug negative 4 into this original formula, and whatever our y comes out to be, that's going to be the y value of our vertex. Okay, so when you plug and chug, you get y equals negative 1, which is what we suspected, right? So our vertex is negative 4, comma, negative 1. All right, let's do one where we don't have the graph. So we don't have the graph here for this one. Y equals negative 3x squared plus 6x minus 7. So we have to figure out a and b so we can plug it into our special axis of symmetry formula. When we plug that in, we get x equaling 1. That's kind of nice because it comes out nice and pretty. Then we're going to take that 1 and plug it back into the original formula. And we end up with y equals negative 4 when we do all our calculations. So our vertex is 1, negative 4, and that's all there is to it. Okay, so today's goal is basically to figure out how to find your vertex, how to find your axis, your axis of symmetry, and how to find your min and your max and your zeros. So that's what your homework is going to be tonight. I'm going to have a Google form for you. And if you have any questions, please let me know. All right, have a great day.